Okay guys, welcome back. In today's class we want to continue from where we stopped. We want to look at nomenclature, but this time around we don't want to talk about alkanes nor alkanes, but we want to talk about bicyclo compounds. Now, as the name implies, bicyclo, bi, it's another way for somebody to say di, which means two. Cyclo is a ring compound. So bicycloalkanes is basically a compound that has two rings fused together to form one. Okay, so we're going to be looking at the easiest and the simplest way to name this compound directly, and then we move to the next step. Now let's look at the example of bicyclo compounds. I have something like this. Now you can also have something that looks like this. Now all of this, they are bicyclo compounds. Okay, so if you see something like looks like this is a bicyclo. Now this place there is, so there's a space there. So we have 1, 2, and 3. So how do we name bicyclo? Okay, let me give us a clue. Now in bicyclo compound, like I said, bicyclo simply means two rings coming together to form one. There will always be a bridge carbon. Now bridge carbons appears to be the two carbon atoms where the two rings appears to join together. So if you look at this guy, this is a bridge carbon and this is a bridge carbon. If you look at this is a bridge carbon, this is a bridge carbon. Now we call this guy bicyclo because this compound can be seen as two ring compound, which is this, and this. So the reason why we call him bicyclo is because it is seen as two ring compound. So if you actually break this further, this is this and this, as you can see it is two ring. So this point where the two rings are fused together is what we call the bridge carbon. So if you want to name bicyclo, you have to take into consideration the bridge carbon first. So let's name this particular compound. Let's see the steps. Step 1, count the total number of carbons present in this compound, the entire carbon that is present in this structure. All right. Now number 2, once you've counted the total number of carbons present in the compound, count the number of carbon on the left hand side of the bridge carbons. Number 2 is for us to count the number of carbons on the left hand side of the bridge carbons. And then number 3 would be count the number of carbons on the right hand side. Number 4, count number of carbons. At the center. So let's use this as an example to name this. So the first thing first is for us to count the total number of carbons present here. So if you would join me, so let's count. Let's start from here. This is carbon 1, carbon 2, carbon 3, carbon 4, 5, 6, right? Now there is a carbon here. Remember, in chemistry, there's what we call line formulas, which is also known as skeletal formula. So anytime you see a compound being represented with just a line, and of course a vertex, right, it's line formula. So in line formulas, all these points, every vertex or intersection is seen to be carbons. So these points are all carbons. Okay. Now this ring is 6 plus additional 1 carbon here. There is a carbon here, 1. So the total number of carbon here, total carbon is 7, and 7 carbon alkane is called heptane. Okay, follow me. Now they said count the number of carbons on the left hand side of the bridge carbon. So you come here, this is the bridge carbon, I put asterisk here, I put asterisk here. Okay, the left hand side of this is the 2 carbon we have, carbon 1 and carbon 2. Okay, let's say this is A and this is B. The left hand side has 2 carbons. So I'll say left hand side equals to 2 carbons. Right hand side of this bridge carbon is also 2 carbons. This and this. Let's move this. So right hand side is also 2 carbons. Okay. So the next thing you're going to do here is to look at the center. The number of carbons that we have at the center is just this point. So at the center, 1 carbon. So what we are simply going to do for us to get the name of this compound, we'll come here and we will say bicyclo. We must start with bicyclo is a must. Then you open a square bracket, arrange these numbers in decreasing order. Now it doesn't really matter which one was at the left hand side or which one is at the right hand side, right? So arrange it in a decreasing order. So this is 2, you put a dot, 2, you put a dot, 1. What was the total number of carbon here? Heptane. And that is the answer to that question. Okay, so let's look at these 2 examples here. We have another example, this and this. So if you want to name this, how do we actually name this particular compound? Anyways, we're just going to follow up from what we did previously. So here is for you to count the total number of carbons present here. Do not forget that. Now, how do we know carbons? Each of these vertex all represents carbon. So this is 1, carbon 1, carbon 2, carbon 3, 4, 5, 6, 7, and 8. All right. So total carbon equals to 8, and this is going to give us octane. 8 carbon alkanes is octane. Okay, so the left hand side of this would be, the left hand side has 1, 2, and 3. So left hand side equals to 3 carbon. Right hand side 1, 2. So right hand side equals to 2 carbons. Now the center equals to 1, just 1 carbon at the center. So if you actually rearrange this, or if you name this, you start with bicyclo, it's a must. Now put your square bracket. These numbers, arrange them in a decreasing order, right? The highest is written first. This is 3, 2, 1, and then octane. Okay, so after now we're going to look at a case where the name will be given to us and I expect us to draw the structure, right? So let's solve for the second compound here. Now, if you look at the total number of carbons present here, this is 1, 2, 3, 4, 5, 6, 7, 8. Total number of carbon is 8. Now, this is the bridge carbon. Left hand side is 1, 2, 2 carbons at the left hand side. Remember, this point represents carbons. Now, right hand side equals to 2 as well. Center is equals to 2. Alright, so you start by saying bicyclo, it's a must. Now, all these numbers are the same, so you're just going to write them 2.2.2, and then what is the total number of carbons present here? 8. So that is octane. So that is how you name bicyclo compounds. All right, so let's look at the opposite of what we just did now. A case where, let's say they say if the structure of the following. So let's assume they say 2, 1, 1. Hexane, and then they say this time around bicyclo 3, 2, 0, heptane. All right, so we have two questions here. Okay, I could use these points to solve for this one, then I use this space to solve for. I wanted to use this place to solve for both of them. Now, strategically, I gave us this on purpose. Now, a case where they said bicyclo. Now, let me give us a clue, class. Now, if you really want to know if your structure is correct or the name of the compound you're going to give to them is correct, just listen to this. You see these numbers inside the square brackets? Now, when you add it up and add 2 to it, it must always give, it's supposed to give you the total number of carbons present here. Heptane, for instance, octane is 8 carbons, right? So if you say 2 plus 2 plus 2, that is 6. 6 plus 2 is 8. It must correspond to this. Now, if you could remember, the extra 2 we are adding, like I said, you must always, if you add up the number we have inside the square brackets, okay, you always add 2 to it to actually get the total number of carbons present in the compound. Now, this 2 plus 2 plus 2 is 6. And now say for it to have 8, you have to add 2. It's constant. Now, the reason is because these two bridge carbons, we did not account for them. Remember, we only accounted for the ones on the left, the ones on the right, and the carbon at the center. We never accounted for this bridge carbon. All right, so that bridge carbon is what we're always going to add up to test and check if the total number of carbons are complete. All right, so let's do this guy. This is hexane. So if you look at 2 plus 1 is 4. 4 plus 2 is 6 hexane. All right, so let's proceed. Now, I'll say you can start from any side. So I'll come here, I'll put a dot. I'll say this, I'll assume this to be my bridge carbon. Now, the reason why I'm putting a dot is because it will be very easy for me to draw it without making a mistake. I could simply draw a line and then join the dots and I get my compound. Now, on the left hand side, let's put 2 carbons here. I put this and I put this. Right? On the right hand side, just 1 carbon. At the center, 1 carbon. Now listen, it must not necessarily be on the left. You can put it on the right as well. So this is what I mean. These two dots represent the bridge carbons, right? Now these two here, you can put it either on the left or on the right. It doesn't really matter, but I would like to put it on the left. Now this one is just 1 dot. The other one simply means that is the one that will be at the center. All right. So I could choose to first of all join this. This becomes, this, and this. this, and this. Then the one carbon at the center, so that is it. This is what we have here. Okay, now let's look at this next one. Heptane, 7 carbon. So we have here, we come here, we put the 2 bridge carbon here, and then put the first one on the left hand side. We have 3 carbons, so put 1, 2, 3. So I join this, I join this, I join it here, I join it here. These 2 is at the right. Class, make sure you've accounted the first 2 numbers. Usually should be the ones on the extreme. The last one is usually the one at the center. All right, the last number is usually the one at the center. Usually, not always, but usually the one at the center. So these 2 comes to this side, and if you noticed, this guy is there. That means there is no carbon. All right, so we're just going, for us to do this, we put a straight line. Class, a straight line does not mean that it does not show any point of carbon. Remember, if it was something like this would have been a carbon, 1 carbon. If it was something like this would have been 2 carbons here and here. But since it is none of the above, so this is 0. There is no carbon here at the center. Okay, so I believe with this now, we can actually see how to draw a structure of bicyclo if the name is given, or to name a bicyclo if the structure is given. So having done that, you can now go ahead and explore. All right, Delzy, I got you covered. Thanks for watching.